Hello everyone, welcome to my channel Essentials of Electronics. Today we are going to discuss on a different kind of circuit, the Schmitt trigger circuit. The Schmitt trigger circuit is a circuit which converts a sinusoidal waveform to unsymmetrical square waveforms. So we have two BJTs coupled with their emitter shorted together. So this is in a way different from the multivibrators. In multivibrators, we do not feed any input signal, but in a Schmitt trigger, we are feeding the sinusoidal input. And here too, we use two transistors, the emitters of the transistors being coupled in this way, collector resistors with VCC. Let me name this as Q1 and Q2 transistor, P1, E1, C1. RC1 be the resistor connected to the collector of Q1 transistor, B2, C2, E2, and let RC2 be the resistor connected to the collector of second transistor. So we are going to get the output from the collector terminal of transistor Q2 by connecting a resistor in the output of the first transistor. Yes, applying a voltage divider biasing part here, minus voltage is given. Let this resistor be R1, R2 be behaving as the voltage divider biasing, and RE be the emitter feedback bias. The input which is going to be given is a sinusoidal input. So when the input signal is given through RB, yes, the transistor Q1 turns on, giving its output through the resistor. The base of the second transistor is turned on, thereby turning on at different saturation levels and giving its output. Yes, the sinusoidal waveform is converted into asymmetrical output waveforms, and we could collect two different waveforms from the output of collector C1 as well as C2. So this behaves at a certain condition as an oscillator by the help of the VCC voltage. With the help of the VCC voltage and the input sinusoidal wave, the circuit triggers on two triggering levels. One is the upper triggering level and the other one is the lower triggering level. Yes, this meeting points, this is upper triggering level UTL and lower triggering level LTL. Yes, I have named them in such a manner. And the meeting points of the upper triggering level in the positive signal, I am drawing vertical line, and the meeting point of the lower terminal. Again, the meeting point of the upper triggering level and the meeting point of the lower triggering level with respect to the input signal. I have shown vertical lines so that it is easier for us to know what are the output voltages generated according to the timeline. So this is the input voltage, a sinusoidal waveform. So by turning on each transistor one at a time, the square pulses are generated. So when Initially, let us assume that Q1 is off during this period. Let us assume that Q1 is off and Q2 is on. So the output voltage across VC1 will be like this. Let this axis be the output showing VC2. So initially, let us assume that Q1 is in off condition and Q2 is on condition. So when Q1 is off, maximum output voltage is obtained at VC1. Yes. And when at this instant, Q1 is on and Q2 is off. So at that instant, VC1, yes, the capacitor, the VC1, the voltage across the collector terminal shows a minimum value and it is at the same level until the next turn on takes place. Meanwhile, VC2 is minimum when Q1 is off and Q2 is on. When Q1 is on, the voltage across VC increases and it remains like this. At this state, when the lower triggering level and the input voltage are at a saturation point, the VC1 voltage increases and it continues to show an output like this. VC2 is low and again the cycle continues. So we can tell that this is the position when Q1 is on, Q2 is off. This is Q1 off, Q2 on. So this is the output which is generated across both the collector terminals of the transistors Q1 and Q2. Yes. So when an input AC signal is applied to the base of the transistor, as it increases to the voltage sufficient to overcome the reverse bias of transistor Q1 or reaches the upper triggering level, the transistor Q1 starts conducting. The point at which the transistor Q1 starts conducting is called the upper threshold level. When the transistor Q1 starts conducting, the voltage drop at the collector of Q1 drops to minimum. This negative going signal is coupled to the base of the transistor Q2 through the resistor R1. It reduces its forward bias and thus the emitter current and hence the voltage drop across the resistor RE. As a result, the reverse bias of the transistor Q1 reduces and it starts to conduct more. Thus, the collector voltage of transistor Q1 drops. This part. Q1 drops and the transistor Q2 further is driven into cutoff. This process will continue until transistor Q1 is driven into saturation and transistor Q2 is cut off. After a half a cycle of the input voltage, it will be negative going. The transistor Q2 will continue in cutoff till the input voltage falls below the lower triggering level. When it crosses the lower triggering level, transistor Q1 becomes reverse bias due to the negative going input signal. This becomes reverse bias. As a result, the collector voltage of the transistor Q1 rises towards VCC and it is applied to the base of the transistor Q2 through the resistor R1. That is through this resistor R1. This makes transistor Q2 to conduct. The point at which transistor Q2 starts conducting is called lower triggering level. When the transistor Q2 starts conducting, the voltage drop across the resistor RE increases and it drives transistor Q1 into cutoff. This state continues till the input AC signal again crosses the upper triggering level. Therefore, a positive going pulse is generated at the output. This completes one cycle and it is repeated as the input AC signal repeats its own cycle. Thus, using a Schmitt trigger circuit, a sinusoidal wave converts into an asymmetrical waveform, and we could see the reverse voltage of this. So across collector terminal 1 and collector terminal 2. Yes, this is the circuit diagram and its explanation with operation of Schmitt-Trigger circuit. Thank you.